This video we're going to be talking about graphing quadratics in vertex form. So graphing parabolas or my U-shapes. Okay, so first off, a parent function is the simplest form for any equation, and then we will translate or transform those parent functions. So all the parent functions we're going to talk about, we got y equals x squared, that's the one we're going to work with today. Y equals x cubed, we got y equals the square root of x, y equals the cube root of x, and y equals the absolute value of x. Okay, so parent functions are basically your original function before it gets moved around. Okay, translating it is when we move it around. So my first one here is y equals x. So if I add a little plus 0 to this, that means it's going to start on my 0. And my slope, if I don't see a number there, it's 1 over 1. So right one, up one, and then down one, left one. So there's my parent function. Then it's going to do a shift. So adding this minus 2 to it is going to shift it down 2. So it starts at negative 2 on my y-axis and has the same slope, so up 1 over 1. So you can kind of see how my pink graph shifted down 2 to make my yellow graph. Okay, so the y equals x was my parent function, and then we can create a family or different translations based on that. Okay, so all of my equations for parabolas will look like this. Okay, the front here, anytime I multiply a number in front, it will either stretch it or make your points farther apart, or it will compress it and make your points skinnier or closer together. Okay, this outside piece will shift it up or down, and this inside piece will shift it left or right. So it's inside with a parentheses here. Okay, with the squared sitting on the outside, and it is the opposite of what you think for all of these. Okay, so anytime it sits with that x, it is always the opposite of what you think. Okay, so normally we think left would be negative, well, it's actually going to be positive in this. Okay, and then HK is going to represent that vertex as well. So those 2 points there are going to represent the vertex or where my U occurs. So my U, that is going to happen there with my HK. Okay, the other thing with parabolas is sometimes this will be negative out here, so we'll talk about it being a reflection. That also tells me my parabola will open down. Okay, so anytime I have a sad face, that will have to be a negative parabola. So we'll be talking about that in a little bit as well. Okay, so graph y equals x squared and y equals x squared plus 1. Okay, so if I don't add any numbers to this, I can add zeros for my h and k. So this represents the exact same equation. So my u is going to start at 0, 0. And then with parabolas, we have this 1, 3, 5 going up. Okay, so I always go right one, and then I follow that 1, 3, 5. So right one, up one. Then from that point I just did, I go right one, up 3. From that point, I go right one, up 5. And I can mirror off the left side there. So I go left one, up 1, left one, up 3, and then left one, up 5. And that's my basic parabola. That 1, 3, 5 will get me that basic parabola U. Okay, so you always go right one or left one, and then this 1, 3, 5 tells me how much I move up. Okay, so my next one here, that plus 1 sitting on the outside is telling me that I am going to be shifting it up 1. So my whole U will shift up 1. So if I look, there's still, for my h in here, it is still a 0. Okay, but my k value is now a 1. So my hk or my vertex will be 0, 1. So it shifted up 1. And I still do my normal 1, 3, 5. So I go right one, up 1, right one, up 3, and then right one, up 5. Then I mirror left one, up 1, left one, up 3, left one, up 5. So there is my U shifted up 1. Okay, so if there's a plus 1 on the outside, it's up 1. If it would have been a minus 1, it would have gone down 1. So any of those outside numbers will move it up and down. Okay, we got vertical stretch. So we're multiplying anything, so it's the numbers that get multiplied in front of your equation. Okay, so to stretch it, my points will get farther and farther apart, or my picture could get fatter. So it needs to be a number that's bigger than 1. So an example could be 2, 3, 4, 5, 6. Okay, compressing means all my points get smaller together. I'm compressing it down, they get closer together, or my graph could get skinnier. Okay, so an example of that, it has to be between 0 and 1. So I could say y equals 1/2 squared. Be wary of fractions. So if I have 3 over 2, that is still 1.5, which is bigger than 1. So it would still be stretching or getting my points farther apart. Okay, so that number, stretching and compressing, always goes in front of your x squared. Okay, so this 2 is going to stretch it, so my points will get farther apart. So graphing my regular, it starts at 0, 0, right one up 1, right one up 3, and then right one up 5. And then I mirror, so left one up 1, left one up 3, left one up 5. So there's my original, and now I'm going to show that stretch of 2. So my points are probably going to get farther apart. Okay, so it's still at 0, 0 because my h is here, my k is out here, so 0, 0 doesn't change it. But now my 1, 3, 5, I need to multiply by the number in front because that's going to make those points move. So 1 times 2 gets me 2, 3 times 2 gets me 6, 5 times 2 gets me 10. So I still go right 1, but this time I'm going up 2. Then I go right 1, up 6. So you can see, and then I go right 1 up 10, but that one doesn't even fit on the graph. So my points are getting so far out, they're stretching so much that they're getting farther and farther apart. So my next one, left 1 up 2, left 1 up 6. And that next one isn't even going to fit on the graph again. So you can see the points stretching farther apart. We're vertically stretching it. Okay, my next one's going to be a compress. Okay, so it's going to get closer and closer together. All right, so my original 0, 0, right one up 1, right one up 1, 2, 3, right one up 1, 2, 3, 4, 5. Come on. Left one up 1, left one up 1, 2, 3, left one up 1, 2, 3, 4, 5. I put that dot 1 too low over here. There's my original. So now we're going to see all of our points get closer together. So I need to multiply my 1, 3, 5 by 1/2 this time. Okay, so 1/2 times 1 is 1/2. Half of 3 is 1.5. Half of 5 is 2.5. Okay, so I go right 1 up 1/2. I go right 1 up 1.5 from there. So I'm like moving partial of the way. Right 1 up 2.5. So I went up 1, 2.5 way there. Then I mirror. I go left 1 up 1/2, left 1 up 1.5, left 1 up 2.5. Okay, so all of my points kind of moved down a little bit. They all got really close together. So that is your compress. You're compressing your points to get closer and closer together. All right, we also have reflections, so it's going to flip across certain axes. So if the negative sits in front here, it's going to reflect over your x-axis. So if I have my u here, this is my x-axis. So reflection over the x, it's going to make it a sad face. Okay, so anytime it says opens down or reflects over the x, it's going to be a negative in front. Think sad face, negative, okay? If it reflects over your y, it's just going to mirror to look the same in this situation. Okay, if I had my parabola sitting out here and it mirrored over my y, it would now be over here. Okay, so that's when we have to build a set of parentheses, and that negative is inside the parentheses. You won't see this very often, but it will occur. The way that I remember reflection over the x, you always keep your ex-boyfriend or ex-girlfriend outside. You keep that negative outside your parentheses. Okay, if it reflects over your y, you want it inside the parentheses. All right, so we're graphing f of x equals negative 2x. Remember, f of x we could also write as y. So if I add a little plus 0, I know it's going to start at my origin, and then it's going to go down 2 to the right one, because remember, if it's a negative slope, it's a decreasing line, or up 2 to the left one. So there's my original. Okay, and then I'm translating it this. So outside means up or down, so I'm going down 2. Inside means left or right, and it's the opposite of what you think. So you think plus means right, but you're actually going to be going the opposite. So we're shift them all left 1. So all of these points I'm shifting left 1 down 2. So if I take this first one here, I go left 1 down 2. So left 1 down 2. Then I take my next one, left 1 down 2. Then I take my next one, left 1 down 2. My next one, left 1 down 2. Left 1 down 2, okay? And then I would connect all those points so you can kind of see how that graph shifted. It looks like it just went left 2. That's why lines are a little bit different. But that's how you can shift it based on just the translation equation. Okay, so my next one, write an equation for each transformation. Here's my parent function y equals x. It stretches by 4. So that 4 always has, stretching and compressing always gets multiplied in the front. Okay, so vertically stretch, it goes in the front. Vertically compress by a half, so all my points get closer together. It still goes in the front. Okay, my next one, we are doing f of x equals 4x squared. So translating it up 5 and reflecting over x. Remember, we keep our x outside. So we are going to, for the reflection over the x, keep that x outside. The negative goes on the outside, and I forgot the 4. Okay, now let's work the other piece. Up 5 units, up and down is on the outside. So up 5 units, all we have to do is add a little 5 here. Left and right would be inside the parentheses. The next one, it says reflecting in the y-axis. Okay, so I would have to put my negative inside my parentheses with the x. Then it says vertically compress. So my points need to get closer and closer together. So to compress something, you need to multiply by something smaller than 1. So we're just going to say a little 1/2. That's going to get me smaller than, ooh, it says 1/8. And I forgot the 4 again. So hold on. So back to, oops. So we have the 4. Okay, so that was just a reflection over the y. And then it said compressed by 1/8, so that 1/8 has to go in the front again. So 4 times 1/8, and we still got that negative x squared. So let's just simplify this to get 1/2. And that negative still sitting on the inside with this squared on the outside. If we would have had to have gone left or right, there would have been something in the parentheses, and then up or down, something would have been out here, but we didn't have to. Okay, find a way to change the equation y equals x squared to open down. So I need a sad face. Sad face means negatives in front. Okay, then it says move up 2 units. So that moving up and down is always on the outside. It's normal. And 5 units left. So that's going to be inside. And it's the opposite of what you think. Okay, so it needs to go inside the parentheses with the x. So normally we think left is negative. So it's going to be a positive 5. And then don't forget your squared to make it that parabola. That negative is just still chilling on the outside. Okay, find a way to change the equation to make y equals x squared open down again. So we got a negative x squared, makes me my sad face. And then vertically compress by 1/2. Compression and stretching always get multiplied in the front. And then it says move 2 units down. So up and down occurs on the outside. To go down, we just need a minus. Okay, because this stands for your y value, which means up and down. If it was on the inside, it stands for your x value. That's why it moves it left and right. Okay, so we're going to graph some of them, state the translations. So this means we are going up 5. This is going to be the opposite of what you think, so right 1. This one up 1 because it's sitting on the outside. We are going down 4 and left 4 because it's opposite of what you think. Okay, to get your HK or your vertex where your U is going to be, we always flip this one because it's opposite of what you think. So 1 and my 5 stays normal. So that's where my U is going to occur. So right 1, up 1, 2, 3, 4, 5. I check to make sure there's nothing sitting in front, because if there is, then I would need to multiply my 1, 3, 5, and there isn't, so we're just going to do right 1 up 1, right 1 up 3, and then my next one would fall off. So left 1 up 1, left 1 up 1, 2, 3. Okay, my next one here, my H that sits in here is going to be a 0, and my k is that outside number, so 1. So I got 0, 1. I checked to make sure there's nothing in front that I need to multiply my 1, 3, 5 by, and there's not. So I do it normal. So right one up 1, right one up 1, 2, 3, and then right one up 5. And then I mirror left one up 1, left one up 3, left one up 5. Okay. My next one here, we flip my x when it comes out, so it's a -4, and then this one stays normal, so -4 again. So I go left 4, down 4. There's nothing in front to multiply by, so I got my normal 1, 3, 5 going up. So I go right one up 1, right one up 1, 2, 3, right one up 1, 2, 3, 4, 5, left one up 1, left one up 1, 2, 3, left one up 5. And there's my U. If it would be a negative in front, then it would be going downward and it would be a sad face. Okay, so those are your ending graphs here.